it by hand and then plugging that there? No, you do not, right? So what do you do for these? To find the acceleration vector, what should you do? What function on your calculator do you use? Yeah, use the end deriv, and then you're going to use the end deriv for dx dt when t is equal to what? 2. And the same thing for dy dt when t is equal to what? 2. It's the same exact thing. You don't get any round something, it's just to chop off the fourth and next digits, or to round it if you see 5 go up. So actually there's 4 here. So here's the acceleration, here's the speed, which is just the square root of those values squared. Does it what? Rise over what? Run. But in this case, what's our measurement of rise and what's our measurement of run? What's our measurement? dy dt and what? dy dt over dx dt. So so undefined means that is undefined. So therefore the denominator needs to be what? The denominator needs to be 0. But what is dx dt? That's sine inverse, right? So you have dx dt is equal to what? Sine inverse of what? 1 minus 2e to the negative t, like this. So what do we do with that value? What do we do with this? Set it equal to what? 0. And what do you use to solve that? You can use your calculator. You could also do this one. You could actually do by hand pretty quickly, because what is sine inverse of z? You have sine inverse of 0 is equal to 1 minus 2e to the negative t. What is sine inverse of 0? Anybody know? The sine of what is 0? Is 0. So you have 0 is equal to 1 minus 2e to the negative t. So you have 1 is equal to 2e to the negative t. So you have 1/2 is equal to e to the negative t. So you can do this by hand if you want to, right? So what's that going to be? That's log base e of equals negative t, right? This is ln of e to the, it was 1/2 ln e is equal to negative t. So what's t equal to? Negative 1/2. So you can do that one by hand, but here's the thing. When you see this, just do it on your calculator. Might be easier. What is dy dt? T cubed, and this is over 1 minus what? Sine inverse of 1 minus 2e to the negative. Is that correct? So what is it asking you to do? It's asking you to do the limit as what? T goes to infinity. Oh, it's not 1 minus. I'd put an extra one in there. Thank you. Whoops. So you have this. 4t over 1 plus t cubed. And then you have times 1 over sine inverse. And you might be a little bit anxious at the moment because it's not the best limit. It's also not the worst either. Also, you need to be very careful about this. What do you notice about the first thing right here? What happens to the first? What happens to this as t goes to infinity? What does that go to? 0. Does that automatically mean the whole thing goes to 0? No, you have to do analysis on the second part. Just because it goes to 0 in one place, the other part could go to infinity, and then you have to do careful analysis, because if you have something going to 0 and something blowing up to going to infinity, what are the 3 possible categories of answers? Either it goes to 0, or it gets infinitely big, or it goes to like 7. My favorite ones are the ones that go to 7, personally, because it means that the forces have canceled each other out and all that's left is 7. In this case, you can do some math, though. Specifically, you need to answer this question right here. You need to answer the limit as t goes to infinity of e to the negative t. What is that? That's the limit as t goes to infinity of what? 1 over e to the t. So what's that equal? What's that equal? 0. So what happens right to this thing? What does that go to? 0. So what does this limit equal? This limit is equal to the limit as t goes to infinity of something that goes to 0 times what? 1 over sine inverse of what? You don't even care what sine inverse of 1 is, because that's a static number. So therefore, what does this limit equal? Is 0. All done. All done. Yeah, f, I guess, is right, if it was f of x. But it's y of t, and it's y naught, and instead of dx dt, it's what? dy dt. Here's the thing. In the original question, does it tell you where the particle is at time 0? Does it tell you where the particle is at time 0? No, it says at time 2, it's where? 6, -3. So do you have to start at 0 in this integral? No. The position of yt is going to be equal to the position at when it's 2 plus 2t, and what is it? It's 4t over what? 1 plus t cubed dt. But what is y2? What was that point? At t equals 2, the point was at what? 6, negative 3. So what do you plug in for y2? What? Negative 3. So the y position of this particle is negative 3 plus the integral of 2 to t of 4t over 1 plus t cubed dt. That's the position. If you wanted the y coordinate, at time t, you would take negative 3 and you would add to it the net change in y position from times t. You've done this a bunch in AB calculus. So if you wanted the x one, if you wanted the x coordinate, it would be xt equals 6 plus the integral and it would be dx dt instead. At 2. Exactly. Now here's the thing. This is not what the question asks. We have to add in one thing. What does it ask in the question? It says an expression involving an improper integral that represents this value of c. So it has a horizontal asymptote. So the horizontal asymptote, it gets infinitely close as t goes to what? So c is going to be equal to the limit of what? As t goes to infinity of negative 3 plus the integral from 2 to t of 4t. And why is it really nice that they said write but don't evaluate? Yeah, you really don't want to do that, right? No, why not? Why does that integral scream like go away? Or what's one find the interval of convergence? What do you always have to run? Ratio test. So we're looking at the limit as n goes to infinity of an plus 1 over. So this is called be really super careful. And are we doing this for f or g? To f. So what do we have? We have the limit as n goes to infinity of negative 1 to the n plus 1, n plus 1, x to the n plus 1, all over n plus what? 2 times the reciprocal of the original. So n plus 1 over what? Negative 1 to the n, and x to the n. So you just need to do this limit right here. Now, it's all glued together with multiplication. So what can you tell me if I took this n and this n plus 2 and this n plus 1 and this n plus 1? What happens to that piece as n goes to infinity? What does it go to? It goes to 1, right? Because what's the power of the n's on top? 2. What's the power of the n's on the bottom? 2. Does everybody understand what? It goes away. It goes away. Why? Field goal? Because the field goal? The absolute value? The absolute. Flattens it out, makes it go to 1, right? So this equals the absolute value of x to the n plus 1 over x to the n. What does that equal? X to the what? 1. First, and for that to converge, what does that have to be? Has to be less than 1, correct? But then what do you have to always test? You'd only get like 3 points out of the 5 if you stopped here. You have to be real careful. You have to test the endpoints. And how do you test endpoints? Go really just plug it into the original. So if x equals 1, you can just plug 1 into these pieces, right? It's already done it out for you. At first, I was like, okay, let's plug it into this and do it all the hard stuff in our head. Look, they've already simplified it out for you, right? Like, don't forget that they listed it out. So when you plug in 1, what do you get? Negative 1. Plus 2/3 minus what? 3/4. Does this converge or diverge? Does it converge or diverge? It diverges. Why? How do you know it diverges?
Because it has alternating, but
it's alternating, but the absolute value of each term is greater than the previous. Correct. It goes big, right? Can't happen. So what happens when x is negative 1? What happens there? 1/2 plus 2/3 plus 3/4. What happens to this? This definitely what? Diverges, right. That definitely diverges. So what's the final answer? Yay. Does it ask, what does it ask for? It says, you have to make sure you say specifically, it says, find the interval of convergence, justify your answer. There it is. Spell it out for them. You tested the endpoints, neither of them worked, so it's not equal to either of them. What does it ask you to find? This is really important. What does it ask you to find?
Whether y.
No, it says find. It literally says find these, right? Correct? So if y is equal to f prime, if y is equal to f minus g, what does y prime equal?
F prime
minus G prime of x, right? So y prime of 0 is equal to f prime at 0 minus what? The quickest way to evaluate this is to find the derivative and plug in 0. And you're like, man, this is going to be terrible, right? Look what they give you right here. Look what they give you in the problem. Where is it? Right here. On f, you see f right there? Can someone tell me what f prime is? What is f prime of x? Someone tell me, just do negative half plus what? X minus 9x squared over 9. 4, sorry, 4, right? 4. And you could keep on going, and maybe you're tempted to do the general term, but here's the thing. All of these terms will have what in it in the numerator? X. So what is f prime of 0? Oh, look, negative 1/2. Oh, does something similar happen here? Sure does. What's g prime of x? Negative 1/2 plus 2x over what? 4 factorial minus 3x squared over 6 factorial. What's in all of these terms? X. So what's g prime of 0? Negative 1/2. So therefore, you end up with negative 1/2 minus negative 1/2. So the answer to this is 0. So we found the first derivative evaluated at 0. So what do you have to do next? How do you do this one? Same exact thing. Look at the chain. Look at the functions you're dealing with. What happens when you then take the derivative of the derivative we just took? You get the different coefficients. Exactly. They're going to be slightly different. But it's the 4/3 on one. There's a factorial in the other one.
Yeah,
Like, look. If you do, so what is, so use, let me use a different color here just so you can see it a little better. But what is f double prime of 0 going to be? It's going to be 4/3 right there, right? And what is g prime, d double prime of 0 going to be? 2 over, it's 1/12, right? So what do you end up with? You end up with 4/3 what? 4/3 minus 1/12, which is equal to 16 over 12 minus 1 over 12, which is 15 over 12, which is 5 over 4. So we're not done yet, though, because what does it ask us? Or it says find these two things, determine if y has a relative minimum or relative maximum or neither. What is it?
A relative max.
It's a relative what? Max or min?
Max.
Why?
Because y double prime of 0 is
Greater than,
greater than 0.
which means what?
Y prime of 0 is increasing.
No. What does it mean for the second derivative to be positive? Concave up. Concave up. And because y prime of 0 is 0, what does that mean is happening there? So it's a min or what? It's a min or max. So therefore concave up and points to a min, so it has to be a concave up. No, yeah, so it has a bottom. Look, if it's concave up and you're at the bottom of concave up, what does that mean? It's a what? It's a minimum. Concave up, smiley face. I'm at the bottom here where the derivative is 0. Let's see what the wording is, just so you can get the